so in this module we'll learn how to find the heat capacity of a gas very quickly. So let's first understand how to actually do it. You have this particular container, you have this container. This container has some gas present. So this gas you apply some amount of heat Q, right? And you know that some of this heat will be utilized to increase the internal energy of the gas, and that is only when the temperature changes, by the way, and some of it will be used to do some work. So they are related using this quantity. Now most of the problems in thermodynamics will just ask you to use this one law, wherein two of these quantities, you have three quantities here, right? Three quantities. Two of these quantities will be indirectly given and the third one will be asked, right? Two will be indirectly given. Sometimes they can be directly given, sometimes they are indirectly given, and then you have to just find the third quantity. Remember, the formula for delta U is always NCV delta T, no matter what the gas is, right? If you just know the temperature change, if you just know the CV of the gas, by the way, right, CV's formula is R by gamma minus 1, where gamma is 1 plus 2 by F, where F is the degrees of freedom of the gas, right? F is degrees of freedom of the gas. Using that, if you remember the degrees of freedom of a gas, depending upon whether it's monatomic, diatomic, polyatomic, if you know F, you can get gamma. If you know gamma, you can get CV for the gas, and N into CV into delta T is delta U. No matter what your process is, your delta U will always be NCV delta T. What will change with process is your Q, because your Q is NC delta T. This is NCV delta T, this is NC delta T. This C is process dependent. The C is process dependent, right? Also your work is integral PdV, right? So if you know pressure as a function of volume, you can always get this, right? But not always you'll easily be, you'll always have pressure as a function of volume easily available. So sometimes you can't actually calculate this. You can calculate this, you can calculate this, and using these two you'll have to calculate this. It's not always possible to calculate work directly, right? So how do you get NC delta T? You should know the process first of all. This is your process. This PV bar x equal to constants represents all process, whether it's your isothermal process, whether it's your adiabatic process, whether it's your isobaric process. This represents all the processes depending on the value of x. If it's your isobaric process, then your x is 0 because P will be constant, isobaric, right? If it's your isothermal process, if this process is your isothermal process, PV is equal to constant, so your x will be 1, right? Likewise, you can have, if your x is equal to gamma, right? You already know what gamma is, 1 plus 2 by F. If your x is equal to gamma, then it's your adiabatic process, right? So some 3 to 4 standard processes are taught to us. Likewise, you have multiple processes. Once you identify the process, you have to use this particular formula to calculate C, right? CV is already known to you because you know the gas. R by 1 minus x, once you get x, you can get R by 1 minus x, you can get C. Once you get C, you just need to find delta T to find Q, right? And that's how you'll you'll have to find two of these quantities, and the third one can actually be got using this particular equation.